Most ECE students are confused. RTL, DFT, PD, verification. Which role is best? Which has more jobs? In this video, I'll simplify everything. VLSI stands for Very Large-Scale Integration, designing chips with millions or billions of transistors packed into a tiny piece of silicon. Every processor in your phone, laptop, or car, made using VLSI. Think of it like building a skyscraper. One team draws the blueprints, another checks for errors, another lays the foundation, another tests the structure. VLSI is the same. Each role handles a different phase of chip making. Here are the 5 main roles you'll see in every semiconductor company. Let me walk you through each one, simply. Role 1. RTL Design Engineer, Front-End. RTL Design is the starting point. You write hardware code using Verilog or System Verilog. You design logic blocks, counters, FSMs, arbiters, pipelines. Think of it like software coding, but your code becomes actual hardware. If you love coding and want to build the brain of a chip, this is your role. Tools can be used. VCS, Questa, Vivado. You'll spend a lot of time in simulation, checking if your logic behaves correctly. Role 2, DV Engineer. Your job in DV? Break the design. Find bugs before the chip is manufactured. Because once a chip goes to the fab, fixing a bug costs crores or millions. You write test benches in System Verilog using UVM, Universal Verification Methodology. Drivers, monitors, scoreboards. You build a full test environment. More coding than RTL, actually. You also write assertions and track coverage. If you enjoy debugging and testing, DV is a great place to be. Point at Basic Requirements bar on slide. M.Tech is preferred here. OOP knowledge in System Verilog is a must. Python or Perl scripting is your plus skill for automation. Role 3. Physical Design Engineer. Physical design is where your RTL code literally becomes a physical layout on silicon. You take the synthesized netlist and place every logic cell, connect every wire, and route the entire chip, following strict timing and power rules. This is called the RTL Design flow. Floor plan placement, CTS, routing GDSII. That GDSII file goes directly to the chip fabrication factory. Timing is everything here. You'll spend days fixing setup and hold violations. Tools, Cadence Innovus, Synopsys ICC2, Primetime for STA. Point at Basic Requirements bar on slide. TCL scripting is mandatory. Almost all PD tools are controlled via TCL commands. Liberty files, LEF definite. You learn on the job, but knowing them early helps. Next role. Role 4. DFT Engineer. DFT, designed for testability. After the chip is manufactured, how do you know if it's defect-free? That's what DFT engineers solve, before the chip is even sent to the fab. You insert scan chains into the design, special logic pods that let you test every flip-flop after manufacturing. You use ATPG tools to automatically generate test patterns. BIST, built-in self-test, lets the chip test itself. And JAD, the IEEE 1149.1 protocol, is your standard interface for all of this. If you like the intersection of design and testing, DFT is niche but in high demand. Verilog plus basic System Verilog, Tessent or DFT compiler tool knowledge, gate-level simulation experience is the plus skill that interviewers love. Next role. Role 5. Functional Safety Engineer. This is the most specialized role, and it's growing fast thanks to EVs and ADAS. Functional safety engineers work on automotive chips where failure is not an option. You follow the ISO 26262 standard. It defines ASIL levels from A to D. ASIL D is the highest, like airbag controllers and steering systems. You do FMEDA, analyzing every possible failure mode and its effect. You design redundancy, like DCLS, dual-core lockstep, where two cores run the same code and compare results to catch faults. ECC, error-correcting codes, for memory protection. ISO 26262 awareness is the minimum. Any FMEDA or safety project experience is gold. Getting an ISO 26262 certificate from TUV is a big plus. Thank you for watching, and all the best for your future.